All right, we are starting our unit on circles, and this first video will just be a lot of vocabulary. So please take your time, pause if you need to, write down these definitions. With each definition, I'm also going to give you a diagram, so that might be more beneficial than the words, but you choose how you learn this vocabulary. So first, a circle is the set of all points in a plane that are equidistant from a given point. That's what we mean by a circle. And then the center of that circle is that point, which all points of the circle are equidistant. So hopefully those are familiar terms for you. Radius is a segment from the center of the circle to any point on the circle. And then a chord is a segment whose endpoints are on a circle. Now the diameter is a chord, it's a specific chord, and that's the chord that contains the center of the circle. These next two might be new to you. Secant. A secant is a line that intersects a circle in 2 points. And a tangent is a line in a plane of a circle that intersects the circle in exactly 1 point. So let me show you all of these terms in a diagram. So we've got this circle. That's what the black line is. And the green is a radius. We have the center is the red dot. A chord could be either of these blue segments. So notice that this blue chord says the endpoints are on the circle, but it does not contain the center. Whereas the diameter is the blue segment that goes through the center. All right, so then we also have these new words. Secant. Secant is a line. So the difference between a chord and a chord is a segment, and the segment stops there. A secant keeps on going past the circle. All right, so a secant's a line, chord is a segment. Tangent. The tangent is a line, and then it only touches it once. So it's like skimming the surface of the circle. And where it touches the circle, that's called the point of tangency. All right, so we have a few things going on here. Let me focus on one thing at a time. The central angle. So when I say, it's important, we're going to talk about different angles that we see in a circle, so make sure you know the difference between them. A central angle has the vertex at the center of the circle. So if I have the central angle APB, that would be a central angle. Now, a minor arc is formed by a central angle that is less than 180 degrees. So let's say this was 100 degrees. Okay, then the arc, the minor arc, which is this red arc, so the arc is what traces the actual circle. Notice that the angle is inside of the circle, but the arc is the actual edge of the circle. All right, and then that arc would be the same as that central angle. So if that central angle is 100, then the minor arc is 100 degrees. And then we also have a major arc. A major arc is formed by a central angle that is greater than 180 degrees. So if I were to do, let me use green. This arc right here, the green arc that I just drew, that's going to be 260 degrees. All right, so that would mean that this major arc is also 260 degrees. Now some other terms that you need to know. Semicircle, that's half of the circle, so an arc whose endpoints are the diameter. So if I have a semicircle, there's the center, there's the diameter. So this would be the semicircle. And if I know that this is a straight line, the diameter, that's 180 degrees. So a semicircle is also 180 degrees. All right, so congruent arcs are going to be arcs that have the same measure. And they are in the same circle. Here's the symbol for circle, just an actual circle. Or they are in congruent circles. So what do I mean by congruent circles? Congruent circles means they have the same radius. So they have the same size. Okay, so they're either in the same exact circle or they're in circles that have the same radius. So in this example, I have arc from here to here, which is 180 degrees, and this arc, which is also 180 degrees. Now, those both have the same measure, but do you notice how they have different radius? This is part of this circle and has that radius, and the green one has that radius. So the green one is actually going to be bigger, right? So that's why we can't say they're congruent. They have the same measure, but this actually is going to have more distance around that curve than the blue one. So those are not congruent arcs. Okay. So here we have, again, same measure, 135 and 135. Two different circles, but notice that the radius on circle F is F to G, and then the radius on circle G is G to F. So that is the same exact radius. So these would be congruent arcs. So we're going to talk more about angles. So another kind of angle that we have is called an inscribed angle. And that's an angle whose vertex is on the circle, and the sides contain chords of the circles. All right, so here in the diagram, the red is the inscribed angle. Notice that the vertex is actually on the circle. It's not at the center. Okay, and then the intercepted arc is important. That's going to be the arc that is in the interior of that inscribed angle, okay, and has endpoints on the angle. So that's the arc that we're talking about. All right, so it's inside of the circle, all right? Or I think of it as if these were laser beams shooting out, what arc does it cut off of the circle? Okay, so these are just different diagrams of how an inscribed angle can look. So I showed you one that looked like this green one, but it could have one of the chords, one of the sides of that arc of the inscribed angle could go through the center like the red one. Or in the blue one, notice that both chords are on one side of that center, so they're real close together. So here's a theorem that we need to know. All right, so the measure of an inscribed angle is equal to half the measure of its intercepted arc. All right, so if I want to find the measure of ADB, so here's ADB, that angle measure, that's going to be half of this arc measure. Okay, so whatever this is, that's going to be half of that. Okay, so make sure you are clear that if I have a central angle, so the central angle would be the exact same as that arc, but the inscribed angle is half of that arc. See how those two angles are different? This one's a lot smaller than that central arc, or central angle. Okay. Another theorem that we need to know is that if two inscribed angles intercept the same arc, then the angles are congruent. All right, so if I trace out this angle right here, this is an inscribed angle with its vertex on the circle, okay, and it has this purple arc as its intercepted arc. And then if I trace out this inscribed angle, its intercepted arc is also that purple one. So whatever that purple arc is, these would be half of that. So that's why we know those are congruent, even though we don't have any measures to go by. So for example, we know that angle Y is 62 degrees, and it cuts off this arc right here. Okay, so they're asking, what is the measure of angle Z? Well, angle Z cuts off that same arc, So I know it's going to be the same as this one over here. So this will also be 62 degrees. Related to arcs is a more specific case, and that is if I have an inscribed angle, if that is a right angle, then I know that, so if I call this angle B, then AC has to be the diameter of the circle. Okay, let's think about that for a minute. So if I know that this inscribed angle is 90 degrees, then the intercepted arc, remember that would be this, has to be twice as big, 180 degrees. So that would make that central angle also 180 degrees, which means that that's a semicircle and that this is a diameter. So that'll be very handy for us because the nice things about 90 degrees is that that makes a right triangle. So we need to be on the lookout for inscribed angles that have the diameter. Okay. Another thing about inscribed angles is we can make polygons, all right? Because if I just have a bunch of inscribed angles, then I can make a polygon. So a polygon whose vertices all lie in the circle, that's an inscribed polygon. A circumscribed, remember that prefix circum means around, so a circle that is drawn around a polygon, a circle with an inscribed polygon. So here, this is just some terminology. This polygon is inscribed in the circle, is inside of the circle, whereas the circle is circumscribed, it goes around the polygon. Okay, so just keep those two words straight. All right, so here's our theorem about if we have a quadrilateral inscribed in a circle, then the opposite angles are supplementary. So notice that this is not any particular kind of quadrilateral, any quadrilateral. So this angle down here, angle D and angle B should be supplementary. And then same thing with angle C and angle A. Those will also be supplementary. So we'll have to keep our eyes open for those shapes as well. All right, so if we were to find the value of x in this one, notice that angle C is inscribed in a semicircle, and we know that because this is a diameter. So that makes this a 90-degree angle. So 3x equals 90, so x would have to be 30. And then here we have an inscribed quadrilateral. So then the opposite angles have to be supplementary. So y plus 80 has to equal 180. So y is 100. And then x and 85 are opposite. So x plus 85 equals 180. So x would equal 95.